Hey folks, welcome to the TheCodeCloud. My name is Ravi. In this video, we'll talk about Kubernetes architecture. Kubernetes, also known as K8s, is an open source system for automating deployment, scaling, and management of containerized applications. So let's just understand what is the architecture of Kubernetes. So Kubernetes contains at least one master node. And let's just understand first what are the components of Kubernetes master. There are four major components in the Kubernetes master. Number one is API server, scheduler, controller manager, and etcd. So let's just understand what are these components. So let's start from API server first. It is like brain of the Kubernetes. API server is used for communication between different other components in the Kubernetes using JSON over HTTP API. API server exposed API for almost every operation in Kubernetes. There are two ways to interact with these API. There is command line interface, which is called as kubectl, and you can configure UI interface, that is Kubernetes dashboard. We as a Kubernetes user can interact with these APIs using a tool called kubectl. Kubectl is nothing but a Go language binary. It is a command line tool to interact with Kubernetes API. What is scheduler in Kubernetes master? As its name suggests, it schedules pods across multiple worker nodes. Scheduler watches for newly created pods that have no node assigned. Scheduler gets the information of the hardware configuration of the nodes from the configuration file and schedules the pod on the node accordingly. Ultimately, scheduler is responsible for finding the best node for the pods. Controller manager. Controllers are nothing but control loops. In Kubernetes, controllers are control loops that watch the state of your cluster. They make changes or request for changes whenever needed. Each controller tries to move the current cluster state closer to the desired state. In robotics automation, control loop is a non-terminating loop that regulates the state of the system. Let's just understand this with an example. Let's just take example of thermostat, which is nothing but air conditioners in your home offices. When you set the temperature, it continuously watches the room temperature or office temperature. The temperature 26 should be maintained at any cost. So temperature 26 is our desired state, and control loops does the same. When we have a desired state in Kubernetes, like it should have one master node and two worker node, so it continuously watches whole cluster. The question is how they get to know the current state and the desired state of the cluster. So controller watches the current state of the cluster that is stored in etcd through kube API server and do create, update and delete the resources whenever it is necessary. There are several controllers exist in Kubernetes. Logically, each controller is a separate process, but to reduce complexity. Number one is node controller. What is the function of node controller basically? Node controller responsible for noticing and responding when any nodes go down. Job controller. Job controller watches the job object that represent on or off task. It creates pods to run those tasks to completion. Deployment controller. Deployment controller is responsible for maintaining the replica count. If you set the replica count 3, it maintains the replica count, that means pod 3 in your Kubernetes. If any of the pods go down for any reason, it tries to create another pod. Service account controller. What it does? Basically, whenever you create any namespace, it creates a default service account. What is cloud controller manager? The cloud controller manager lets you link your cluster into your cloud provider's IP. The cloud controller manager only runs controller that are specific to your cloud provider. If you're running a Kubernetes on your own premise or in a learning environment inside your own PC, the cluster doesn't have a cloud controller manager. What is etcd? Basically, etcd is nothing but a key value pair database in Kubernetes. It is consistent and highly available. It is a key value pair database and stores all the cluster data. If you are running a production grade application with only a single master node, you should make sure have at least 2 replica running of your etcd. Let's just see what are the major component in our worker nodes. There are three major component in worker node. Number one is container runtime, kubelet, and kube-proxy. Let's just see what is the container runtime. The container runtime is a software that is responsible for running your containers. Kubernetes supports container runtime such as containerd, cri-o. Kubernetes deprecated Docker as its container runtime. Kubelet is nothing but an agent that runs on each node in the cluster. It makes sure that containers are running in a pod. The Kubelet takes a set of pod specs that are provided through various mechanisms and ensures that the container described in those pod specs are running and healthy. Kube-proxy. Kube-proxy is a network proxy that runs on each node in your cluster. It basically implements the Kubernetes service concept. Kube-proxy maintains the network rules on nodes. These network rules allow network communication to your pods from network sessions inside or outside of your cluster. Kube-proxy uses the operating system packet filtering layer if there is one and it's available. Otherwise, kube-proxy forwards the traffic itself. In the worker node, you might have more than one pod running with one or more containers inside. We have the same concept in worker node too. We should have container runtime, kubelet, kube-proxy, and the pods and the containers. So guys, it is a basic architecture of Kubernetes. Stay tuned. Thank you.